Assalamualaikum warahmatullahi wabarakatuh. Before we begin, let me introduce our team. I am Afika Nabila and the other members are Ahmad Zaru Ikwan, Fatin Fazana and Muhammad Razif Aiman. Together, we have worked on the first fit memory algorithm. To start, I will first explain the concept behind this algorithm. The first fit memory allocation algorithm is a simple and efficient method for dynamic memory management. It works by scanning the memory from the beginning and allocating the first available block that is large enough to fulfill the requested size. Once a suitable block is found, it is allocated, and if the block is larger than needed, the remaining portion is left as free space. While the algorithm is fast due to its straightforward approach, it can lead to external fragmentation as unutilized memory blocks accumulate over time. Despite this, first fit is widely used because of its simplicity and quick allocation process, making it suitable for systems where speed is prioritized over memory optimization.
So this is C++ code for the first fit memory allocation algorithm, which assign its process to the first available memory block that can accommodate it, optimizing memory usage and reducing fragmentation. It defines two main structures, which is block and process. For the block, each representing memory block with total size, remaining size, and allocation status, and process representing processes with required memory size and allocated block number. The first function, which is first fit function, iterates through each process and search for the first suitable memory block that is unallocated and has enough space. Once found, it assigns the process to that block, reduces the remaining size accordingly, and mark it as allocated. So next, the function of display result. This function prints a detailed table showing process allocation, remaining memory in each block, and key efficiency metrics, such as total fragmentation, which is sum of unallocated memory across all blocks, use memory, which is total unallocated memory, and memory efficiency, which is percentage of utilized memory. So next, the main function. The main function takes user input for the number and size of memory block and processes, initialize their attribute, and call firstFit function to allocate memory. After allocation, the display result function is executed to present the final allocation status and memory efficiency. This program effectively demonstrates dynamic memory allocation in operating system, helping to optimize resources utilization while minimizing fragmentation and improving overall memory management efficiency.
Assalamualaikum warahmatullahi wabarakatuh, and I will be presenting the flowchart for this group. First, the system input the number of memory blocks along with their sizes. These memory blocks are then initialized, setting their remaining size and marking them as unallocated. Next, the system takes input for the number of processes and their sizes, and each process is then initialized with a default value, indicating that it is not yet allocated to any block. The system then begins iterating through the process, attempting to allocate each one to a suitable memory block. A block is considered suitable if it has enough remaining space and it is not already allocated. If a suitable block is found, the process is assigned to it. The remaining memory size is updated and the block is marked as allocated. If no suitable block is available, the process remains unallocated. Once all processes have been checked, the system display the allocation result. It then calculates the total used memory, fragmentation, and overall memory efficiency. Finally, it presents the memory allocation status, remaining memory sizes, fragmentation detail, and efficiency metric before concluding the process. This structured approach helps manage memory efficiency, ensuring that process receives the necessary resources while minimizing fragmentation.
Next, I will present the results of our memory allocation program using the first fit strategy. The program successfully allocated memory blocks to processors based on the user input for memory block size and process size. After allocation, the remaining memory in each block was displayed, showing how much space was left after assigning processors. To evaluate performance, we analyzed key efficiency metrics. Total fragmentation varied depending on how memory was distributed among blocks, while used memory depended on the number of processes successfully allocated. Finally, memory efficiency was calculated using the formula, which is used memory divided with total memory times with 100. This percentage reflects how effectively the system utilized its available memory. Next, I will present our observation from the memory allocation process. The first fit allocation method efficiently assigns memory to processors but can lead to internal and external fragmentation, leaving some memory space unusable and reducing overall efficiency. We observed that memory utilization depends on the input, with efficiency fluctuating based on how blocks are allocated. To address this issue, improvements such as the best fit strategy, which allocates the smallest suitable block, and memory compaction, which consolidates free space, could help reduce fragmentation and enhance overall memory efficiency. In conclusion, the first fit allocation method is a fast and simple approach to memory management, making it suitable for systems requiring quick allocation. However, fragmentation can reduce efficiency, leading to wasted space. Its performance depends on memory distribution and process size, but improvements like best fit and memory compaction can enhance utilization. Despite its limitation, first fit remains a widely used strategy due to its ease of implementation and speed.